Hello everyone, welcome back to the Token Minds training series. Today we are talking about settlement risk in banking and how distributed ledger technology allows banks to reduce that risk collaboratively without exposing sensitive balance sheet or client data. Every day, trillions of dollars move through global payment systems, but settlement does not happen instantly. When obligations are delayed, banks face liquidity stress, credit exposure, and operational pressure that spreads far beyond a single institution. To protect themselves, banks hold large defensive liquidity buffers and rely on manual coordination when problems appear. This creates a system that is safe but inefficient, slow to react, and extremely expensive to operate at scale. Traditional settlement infrastructure is built on isolated ledger, delayed reconciliation, and manual escalation between institutions. Distributed ledger technology changes this by enabling banks to share settlement risk signals in real time. So instead of waiting for failures to appear after the fact, institutions gain synchronized visibility into exposure and can coordinate protection earlier using permission networks and cryptographic validation rather than public data sharing. Settlement risk becomes dangerous when assumptions break. So banks plan intraday liquidity based on expected inflows that have not yet arrived. When one institution faces sudden stress, outgoing payments are delayed. So the next bank misses an expected inflow, creating a new liquidity gap. Without shared visibility, each institution reacts in isolation. By the time manual escalation begins through calls and emails, exposure has already spread across the network. What started at a single day delay turns into a system wide liquidity event. This is why defensive liquidity keeps growing across the banking system. Without real time coordination, banks are forced to protect themselves individually, holding billions in excess buffers against uncertainty. Distributed ledgers provide a shared, real time view of settlement status. That visibility allows institutions to respond earlier to stress, reduce uncertainty, and lower both settlement risk and the amount of idle liquidity trapped in the system. Settlement risk is reduced by layering coordination automation and cryptographic assurance on top of existing banking infrastructure. So permission ledgers synchronize settlement state across institutions. Smart contract controls enforce liquidity limits and exception rules before failures occur. Zero knowledge validation allows banks to prove risk conditions without exposing balances. Programmatic governance enables collective response through auditable execution. Event-driven containment connects oracles and automated collateral to stop stress from escalating into default. And the foundation is a synchronous settlement layer. Platforms like R3 Corda, Hyperledger Fabric, and enterprise EVM networks coordinate settlement state across banks without broadcasting sensitive data. Interbank obligations, in-flight payment states, and finality confirmations are encoded directly into the ledger. So models such as settlement state, payment chain code, and finality registry ensure that each institution works from the same execution layer, replacing fragmented reconciliation with shared operational truth. So protection shifts from reacting to failures to preventing them. Smart contract logic rather than Solidity, Kotlin, and Go enforces settlement risk thresholds, intraday liquidity limits, netting rules, and escalation triggers. So instead of detecting problems after payments fail, contracts block execution when liquidity drops below safe levels. Settlement protection becomes executable infrastructure, not after the fact review, turning policy into system behavior. Privacy is preserved by moving from data sharing to proof sharing. Banks generate cryptographic proofs that confirm stress conditions without revealing balances, positions, or strategies. ZK Snark circuits create these proofs. On-chain verifier contracts and Corda ZK flows validate them. Models like settlement proofs, ZK verifier, and proof relay allow institutions to coordinate risk response while keeping sensitive information confidential. So this model is already operating in production. Finality International is a bank-owned consortium delivering tokenized settlement infrastructure that enables atomic real-time payment finality. So major institutions including JP Morgan, Barclays, UBS use this shared platform to remove settlement timing gaps that create unsecured exposure. The design combines a privacy-first model with central bank money settlement on a permission ledger, delivering trusted finality without sacrificing confidentiality. So settlement risk is becoming core financial infrastructure. In the near term, leading banks embed DLT directly into payments, clearing, and trade finance operations. The next phase expands across correspondent banking, security settlement, and cross border liquidity. Longer term, programmable interbank infrastructure replaces bilateral escalation with automated protection that prevent cascading values before they threaten financial stability. So, thank you for watching. If you are ready to build settlement risk solutions that deliver real time coordination, privacy preserving controls, and automated protection across banking networks, reach out to Token Minds. We'd love to help you bring the next generation of financial infrastructure to life.